Hey, everybody, and welcome to my talk for DevFest Wisconsin. This is DevOps Philosophy versus Practice, and my name is PJ Hagerty. I work at a company called Mattermost. Really wish I could be there in person, but of course, we all know why. Maybe next time. Hopefully, I can get out there. So a little bit about Mattermost. We do chat ops. Everything that we do is open source. So plugins, integrations, slash commands, anything that you need to build in there, you are more than welcome to build in there. We also have enterprise options for larger organizations. We do on-prem, but we are cloud ready. And additionally, of course, we have a DevOps Command Center tool that's coming up that's going to be pretty cool. So a little about me. Like I said, my name is PJ. I go by Asplenic on Twitter. There's a lovely story about that. I've been a musician for many years. I'm a dad. I coach hockey, or I did coach hockey till my son retired at the age of 17. And one time I let my daughter keynote RubyConf. I really love communities, and I love talking to people in the community, which is part of the reason why I'm here today. I love to travel the world, talk about technology and people and how that all works together. So enough about me. Let's talk about what you're really here to find out. To say DevOps is a buzzword at the moment is kind of a severe understatement. But what is DevOps? Is it the new Agile? Is it Agile with a little sauce on top? Or is it just a bunch of tooling to bring the development and operation sides together? There's always talk and discussion about the philosophy of DevOps. And these discussions often include big presentations on what it means, but they often touch on only one aspect of DevOps, such as being on call or incident management, automation, or how dev meets ops. But rarely are all the parts examined at once. Here, we'll try to put the philosophy and the tools together in one place. First, let's define DevOps as it stands today. According to the strict definition of DevOps, it's a concatenation of development and operations, a method that emphasizes collaboration between the entire spectrum of professionals involved in creation, development, and deployment of software. While that's pretty straightforward, the definition hardly fits the modern concept. Before going too much further, it might be important to define the so-called parts of DevOps. We start with what should be obvious, the obvious part, development. Is it obvious though? Are we talking about any code that gets written? Just back-end code that serves the functionality of the application? Do we consider front-end code or UI UX important in this mix? What even is development? For our purposes, we'll just say anything I just mentioned is development, the whole kit and caboodle. Next, you have a little thing called QA. You'll notice it's not really in the title, but it's still very important. Devs QAOps or DevOps Qua, none of these words worked and they weren't very marketable. So DevOps just kind of left the QA out, but it's actually a very important part of the whole situation. For most organizations, this starts at the development level with code tests, unit tests, and testing frameworks. Many times it ends here as well, unless we have a large enough organization to have a dedicated QA team. This could be a few people going through end user type interactions or folks running tests against the system for penetration, security, or even just browser interaction. Finally, the last part is we have ops or operations. These are the systems administrators, deployment engineers, SREs, folks making sure the cloud implementation goes well or that we're doing well on our bare metal servers. Anything that needs to go in line with our organizational applicational needs getting deployed. Once these were basement dwelling cable jockeys, but this part of the team has become much more important in the hierarchy of a modern company. Today, we think of DevOps as a set of behaviors and tools that allow a team to function. This idea differs a little from the Agile mindset, which focuses on the ability to move a project along in a flexible timeline, which can be subject to change depending on feedback. As a result, Agile is small, fast, and open to change, but is mostly focused on the software side. It's focused on the development cycle. DevOps looks beyond development and encompasses all the steps from concept to delivery of product. Knowing the parts, though, doesn't mean we understand the ideas behind everything works together. The philosophy bringing this to the forefront started somewhere. In 2008, Andrew Clay Schaefer and Patrick Dubois introduced the first iteration of what we know as DevOps, defining it as a set of practices intended to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. That seems to encompass a lot in the current world of development, so maybe we need to modernize the definition. This philosophy stretches beyond the work cycle. The focus is on how members of a team function, interact, and can be most successful. This means taking into account overarching pieces of the puzzle: development, testing, integration, deployment, monitoring, and systems administration. Pulling this all together requires a tool set, and this chain can be long, I'm not going to lie. There's no single answer to what's the right tool set. It's more about what works for your organization. Some of the key concepts of DevOps are important to understand in order to move forward. And one of the big ideas is automation, as I mentioned before. Automation is usually an idea that strikes fear in the heart of developers and system engineers. In reality, the idea is to eliminate errors, reduce risk, and make our jobs easier. While everyone is lauding the advent of AI and the ease of machine learning, also marketing concepts, the truth is we're writing scripts to help with alerting, monitoring, testing, and other things that can be made easier on a small scale. Automation is not a way to ditch engineers. Another concept that seems to jar the minds of people considering a DevOps culture or adding DevOps to their organization is the idea of chaos engineering. Are we really going to ditch half the production servers at peak times? Are we truly going to drop databases randomly? Not everyone is as comfortable with the way this goes, this way of doing things, but the benefits are clear. Making our systems more resilient in the eyes of our end users is the key to success and our main goal. As I mentioned before, part of the whole idea behind DevOps is ending the siloing in different parts of the organization that are working towards the same goals. This does not mean that we expect folks in payroll to deploy the application or for the CEO to run our CI/CD suite. It does mean that application engineers, QA folks, and systems administrators or ops folks will be working together to make things happen, and they will need some common tools to reach that goal. So this is where we start talking about the tools a little bit and understand that there's a lot of complicated things to answer. When it comes to development tools, there is a never-ending stream of possibilities. First, there are the languages. This is often dependent on what you want your application to do. A simple web-based application, Ruby or Elixir will work well for you. Need something a bit more analytical? Perhaps Python or R would better suit your needs. Want the tried and true language of dependability? Java and Perl should do what you need. And I know I'm doing this remotely and it's pre-recorded, but I heard eyes roll all the way from across the continent. It's unbelievable, but it's actually true. Perl is still a very valuable and important language. In the modern DevOps scenario, the development language is not as important. Factually, you can use combinations of languages to get the specific jobs done within your application. To bring the point home, many applications in modern startups and even large corporations use a combination of languages. Ruby, Java, PHP with a little bit of JavaScript tossed in. This is not an unusual recipe. Just ask the people at Twitter. That's their stack. Languages aside, the key here is making applications that are usable in order to make our users' lives better and easier. That said, we need to make our developers' lives easier as well, which is where things like version control techniques come in. At the moment, the most prominent version control system is Git, but there are still plenty of Subversion users out there in the world. We're lucky enough to not have to run our own repo servers in this day and age, thanks to the cloud. Yeah, I'll talk more about the cloud later. But there are things like Bitbucket, GitHub, and GitLab that take care of a lot of that heavy lifting for us. They also make it easier to share code, and that might be your goal. If you don't want it public, all of these have secure ways of doing that as well. So this is the small rant portion of the talk. I wanted to let you know. You may have noticed there's a slight edge to what I've mentioned in the development section here so far. Almost everything I've mentioned thus far is open source. This point is generally my biggest and most favorite thing. Open source is the way of the future. Collaboration is the way to get things done, but it's also the way of right now. In my much less than humble opinion, which anyone who knows me knows that my opinions are often not that humble, open source is the way we can really establish the best world to realize DevOps practices in. It makes sense. So that's enough of my rant on development tools. Let's talk a little bit about testing. Well, testing is a hot topic among software engineers and has been for quite a while. There are many parts to testing that tools such as RSpec and other code testing components don't reach. Point of fact, I'm a bad person. I hate talking about testing almost as much as I hate writing tests. Almost. Tools here include things like Selenium, which is used for application and browser testing, WAPT, which is an amazing load testing and stress testing tool, and Qtest, which is a suite of tools used for quality control on your application. Additionally, there are services like Rainforest QA that perform the testing on your organization's behalf, testing as a service. Although this is only a partial list, ensuring the stability of an application before it hits the public is crucial. It's part of the Agile framework, which means it's definitely part of the way DevOps works. Testing is a never-ending cycle. While it's part of the DevOps cycle, it's almost kind of a cycle unto itself. Test, analyze, explain, return to sender, deploy. Continuous integration isn't really a new concept either, but it does add to the DevOps toolset in more important ways. Companies such as Travis CI and Circle CI have been working for several years to develop seamless integration of new code into the current operating stack. This could be on sandbox stacks or in production, depending on how solid you feel a deploy can be. Add to this concept the idea of continuous delivery, and we start to approach the end game of our DevOps setup. Like CI, there are great stable CD tools available, such as GoCD, which is not to be confused with the Go programming language, and things like Chef and Puppet. These actually are scripting languages, but they also add to the CD infrastructure. Once we have this, we actually need our literal physical infrastructure. If DevOps is kind of a buzzword, I said that at the top of the talk, it's in good company. Cloud services, containerization, Docker, Kubernetes, and serverless are other buzzwords at the forefront of what we call hosting solutions. That's really what they boil down to. Like programming languages, these answers are organizationally dependent. While serverless may be the wave of the future, some larger companies are just getting into the idea of cloud, whether that be public or private. It's important to note here that enterprise-level business often moves at a glacial pace in comparison to the startup world. Regardless of what the arena, though, DevOps philosophy, adoption of cloud infrastructure, use of open source software solutions, generally the big companies are a bit behind, with the exception of modern behemoths like Facebook or Netflix. They tend to lead the way, but they were also built with modern stacks. While the industry itself is moving forward, it's important to note the adoption of newer infrastructure technologies moves at a much slower pace across the board. For example, organizations are just now beginning to feel safe moving to containers and serverless, and although the cloud has become extremely popular, there are many companies that still use bare metal. Once the decision is made on which new infrastructure technologies to adopt, there's a team of system administrators and operators that come along to handle anything beyond the single application server level. This team will include ops experts, troubleshooters, or even DBAs to look at issues with databases. These operate differently than that of application code. So these operators, systems administrators, all these people that we get together, deployment infrastructure experts, they need their own tools to see the underlying infrastructure systems and what they're doing. A lot of times this is put under one title, which is SRE, which is supposed to be site reliability or system reliability engineer. But it's also kind of a stability engineer. Your whole job is to pay attention to what's going on and understand. And there's great stuff like the Elastic Stack or Humio that can help you actually look into what you're doing and make sure that things are working properly when they're out there in the wider world. The ability to see into our infrastructure and feed that back through the team to improve is quintessential to the success in the market of our application development. It's the end of the cycle, but it's also the beginning. This is another place where we need to be on the watch for buzzwords, though. People love to say things like real time and instant feedback when there's always an underlying delay. The two examples I gave earlier, Humio has a delay that's like less than 1 second, and Elastic can take 4 to 5 seconds, but they both advertise as real time. Watch out for real time. I think monitoring services do their best, but know that your goal is to get there before the customer notices there's a problem. The most interesting part of the tool set used to implement DevOps is the philosophy of communication. The tools here are well known, and I think I've already mentioned the best one, which is Mattermost. The key here is to get everything moving, keep the parts working together. And with Mattermost's DevOps Operations Center, you'll actually be able to collaborate and deal with things like, instant needs when the bad stuff hits the fan, things like that, all in one collaborative place while communication is flowing and moving. It's funny that we include communication as part of the DevOps cycle, though, really, there's no organization inside or outside of tech where communication is not important. Let's be honest. Isn't it really the most important tool to keep any successful team? Any team that wants to be successful has to be able to communicate. Whether working remote or on a distributed team or in a single office, communication is always the key to success. Here we have links to some of the services that we talked about and pieces in the DevOps toolkit that I've proposed. This is not the end-all be-all, and there are other options for each piece of this particular puzzle. In my experience, I've had success with everything listed here. That said, test out what works for you and in your organization. See what fits and what works smoothly. I'll leave this up for a moment, and we'll be able to share the slides online, so look for that on Twitter. Additionally, you'll notice that Mattermost is not there because it's kind of been on every slide, but it's very easy to see that it's one of the best communication tools out there. So Download an instance, see what you can do with it, and have some fun. With competing tools, it's hard to say what the perfect setup will be. Is DevOps the best philosophy for you or your organization? Establishing this is the first of many steps to realizing the potential of best practices within your team and organization. DevOps incorporates both the worlds of development and ops, but it's only a set of tools to streamline your organization. It's not only the set of tools to streamline your organization. It's also the philosophy applied to those tools and the teams working with them. You need to foster an environment of people that work together. All of these elements must come together to improve your application and how it interacts with end users, which is our goal. By bringing together DevOps philosophy and tools, you can empower your team to make successful implementations a reality in your workplace. With that, thank you so much. My name is PJ, and you can find me at Esplenic on Twitter or pj.hagerty@mattermost.com. Thank you for your time, and take care, DevFest Wisconsin.